Hi there, it's time to practice using all of these rational exponents we've been learning about. So on the left and on the right side, there are going to be 4 expressions. Try and simplify them as much as you can. Let's pause the video here and then come back. We'll do them together. All right, let's try them out. So for this first one, we have 2 rational exponents that we are multiplying together here, and it shouldn't be too bad. We know that when we multiply exponents, we actually multiply bases, common bases with exponents. We have to essentially add the exponents together. So that's going to be the same as a to the 2/5 plus a to the 7/5, right? If we add these 2 fractions together, we're going to get a to the 9/5, and that's it, right? That's going to be our final answer right there. Not too bad. Now it's worth thinking about if there are any kind of restrictions on what we can put in for a or what we get out, right? So in this case, since we're taking an odd root, we're taking the 5th root of a, there's no problem with having a negative value for a. So there's no restriction there. And we can get a negative value out because we're taking an odd value of the power. So we can get a negative value in and a negative value out. No restrictions here. Let's take a look at the next one. All right, so this one here is, again, we're multiplying a common base and then dividing a common base. So essentially we're going to add these 2 exponents and then subtract this one, right? So this is going to be the same as a to the power of 2/7 plus 11/7 minus 1/7. And if we do all that, 2 plus 11 is 13, minus 1 is 12. So this is the same as a to the power of 12 over 7. Okay, there we go. That's going to be our final answer there. Now we can think of this as essentially the 7th, let me do this in white, the 7th root of a to the 12th power, right? So that's one way we can think about this. So let's think, can we put a negative number in here for a? Yeah, that's fine. That should be not a problem, right? So we can put a negative value in, and then we're only going to get positive values out, but that's not a big deal. So no important restrictions here. Let's take a look at the next one. Okay, so now we're taking this entire quantity and raising it to the 3/2 power. We can essentially sort of distribute this into each of these numbers here, right? We can distribute a power over multiplication. So this is going to be the same as 8 to the 3/2 power times a to the 5th power to the 3/2 power times b to the 6th power to the 3/2 power, right? So that's one way we can understand this. Now 8 to the 3/2 power, that's interesting. We can think of this 2 ways, right? So 8 to the 3/2 power, we can think of this as either 8 cubed and then we square root that, or we square root a and then cube it. Either way works, okay? Now, typically, it's better to do the root first and then the power, because then you're working with a smaller number, right? If we do the power first, well, it's 8 cubed. 8 times 8 is 64. 64 times 8, that's a big number, and then I have to take the square root of big number. That's just a little more difficult. So it's better to sort of shrink the number first and then make it bigger, okay? So if we deal with the square root of 8, well, I can simplify that. I can think of this as 8 is 2 times 4, right? So all of this is cubed, of course. So I can take this 4 out. I can think of this as 2 rad 2, all of this cubed, right? And now what I can do is I can distribute this 3 in there. So this 2 cubed, square root of 2 cubed, well, 2 cubed is 8. So this is basically equal to 8 times the square root of 8, but I already know what the square root of 8 is. The square root of 8 is 2 rad 2. So this is the same as 8 times 2 rad 2, and that's just going to then equal 16 times the square root of 2. Okay, so it's a couple of steps there, but we can simplify 8 to the 3/2 power. That's going to be 16 root 2. Okay, so that's the first part. Now this next part here, we just multiply these two exponents together, right? So this is going to be equal to a to the 15 over 2. And then we do the same thing here, right? This is a 6, so 6 times 3 is 18, so this is going to be b to the 18 over 2. And we can simplify a little bit, right? So 16 root 2, a to the 15 over 2, and finally this we can simplify this as b to the 9th power, just like that. Okay, so there we go. That's going to be our answer here. Now, usually this is fine. Usually this is all we need to do, but it's worth thinking about if a or b were negative, right? That's where the issues come in, dealing, sort of simplifying rational exponents, is if a and b are negative, what happens? Okay, so now in this case, if a is negative, well, we're raising it to a odd power, so the result would be negative. And, well, then we're going to multiply that power by 3, so that gives us, again, an odd power, and then we're going to take the square root of potentially a negative number, right? If a is negative, we're taking the square root of a negative. We can't do that, okay? So it's worth mentioning there is a restriction here that a must be greater than or equal to 0. A cannot be negative here. That's worth mentioning. Now let's think about b. What happens if b is negative? Well, if b is negative, a negative number raised to an even power will be positive. And so whatever we do after that, if we take the square root of that number, we're taking the square root of a positive number, we will always get a positive number out. And so it turns out this b to the 9th must always be positive. So to be technically correct here, what we would actually want to do is put this in an absolute value, right? Because b to the 9th power, whether b is positive or negative, will always be positive because we're actually going to raise it to the 6th power first, an even power. Okay, so you don't necessarily need to worry about this process right now. We're typically going to be assuming like a and b are positive numbers, right? But if you want to think about what if they're negative, are there any restrictions, we can do that as well. Okay, let's take a look at the next one. All right, so this next one's a little bit more complicated, right? So we've got this whole thing raised to the 5th power multiplied by all of this. I'm going to deal with that 5th power here first. So essentially I'm going to distribute that in across the multiplication and division here. Let's see what we get. Okay, so 2 to the 5th power multiplied by a to the, well, 1/4 times 5 is just going to be 5/4. And this is all over b to the, well, 2 times 5 is going to be 10/3. Okay, so that's what I'm getting for my very first term. And then my second term, well, that's just the same. That's b cubed over a to the negative 1/4, but I'm not going to write this as a negative exponent. Instead, I'm going to write it as a positive exponent, a to the positive 1/4, by bringing it sort of to the top of the numerator there, right? I'm taking the reciprocal, so that'll allow me to get rid of the negative exponent there. All right, so now I can try and combine these two terms together and multiply them together. Well, first of all, 2 to the 5th power, what's that equal to? 2 to the 5th power, that's going to be 2, 4, 8, 16, 32. Okay, so that's going to give me 32. So let's just write down this is equal to 32, and now essentially I have this a to the 5/4 and an a times a to the 1/4, so I have to add these together, right? So this is a to the 5/4 plus 1/4, right? That's what that becomes. And now I have a b. Okay, so let's write down this b. Essentially I have a b cubed, and I have to subtract the 10/3 because I'm dividing here, right? So this is going to be a 3 minus 10/3 like that. Okay, so this is the next step. Let's actually add these exponents together here. So 32a to the, well, this will be a 6/4, and b, well, I can think of this as a 6/3. I'm going to multiply everything here, so this would be a 6/3 minus a 10/3, right? Does that make sense? No, it doesn't. So I have to multiply, get everything multiply by a 3. Okay, so those would be a 9/3 minus a 10/3. There we go. I think that makes sense. Okay, let's simplify a little bit further. A 6/4, that simplifies to a 3/2. And this b, well, this just become a negative 1/3. So if I wanted to, I could actually write this then as a b to the positive 1/3 in the denominator. Okay, and so that I think will be my final answer here. Now, again, let's think if a or b are negative. Are there any issues that we come up with? Well, yes, there is an issue here, right? If a is a negative number, we're taking a 4th root of a. Same thing here. That's an even root. We cannot do that if a is negative, okay? So there is kind of a restriction here. A cannot be negative, right? Now, what about b? Well, b I think is okay because we're raising it to an odd root here. So b is allowed to be negative. We can get a negative number out for b. No issues with that. Just a, we have a restriction there. Okay, let's take a look at the next one. All right, we're working with some radicals now. So what I want to do is translate these radicals into rational exponents. That's going to make it easier to work with them. And let's see what we get here. This is going to be equal to then essentially 4 times 4 times x to the 1/2 power times x to the 2/3 power, right? That's essentially what this is going to be. So 4 times 4, of course, is 16. X to the 1/2 times x to the 2/3. So that's x to the 1/2 plus 2/3, right, in the exponent. So how do we do that? Well, we need a common base, right? In this case, the common base will be 6, right? So this is going to be, instead of 1/2, we treat this as 3/6, and instead of 2/3, we have to multiply top and bottom by 2. That's going to be 4/6, and we can add this together. 3 plus 4 is going to be 7. So this will be 16x to the 7/6. Okay, there we go. And that's going to be our answer here. Now let's think if there are any restrictions on if x is negative. Any problems there? Well, yes, there is. Okay, there is a problem. If x is negative, we'll be taking the square root of a negative number, which we cannot do. And so that is going to tell us that x cannot be negative. Okay, x must be greater than or equal to 0. And then we should be okay. All right, let's take a look at the next one. All right, so here's another one with some more radicals. Again, I want to transform this, rewrite this as a rational exponent. So I'm going to write this as x squared times x to the 1/3 all raised to the 1/3 power. Okay, that's the best way to deal with this. X squared times x to the 1/3, that's the same as x to the power of 2 plus 1/3, right? And of course, all of that is raised to the 1/3 power. Now, how do I do this? I need a common denominator. My common denominator will be 3. So I have to multiply this 2 by 3/3, right? So this will be x to the power of 6/3 plus 1/3 all to the 1/3 power. And that's just going to then be 6 to the 7/3 to the 1/3 power. And now I can just multiply these two together. So that's going to give me x to the power of 7/9. And that should be it. That should be my final answer there. Are there any restrictions if x is negative? Well, if x is negative, well, that'll become positive, but that's fine. If x is negative here, well, then this answer will be negative. I'm taking the cubed root of a negative number. That's no problem, so no restrictions here, okay? X is allowed to be negative. It's not going to harm us. Let's look at another one. Okay, so for this one, I want to try and simplify what I've got inside of this square root. So let's do that. Let's treat this then as the square root. So 27, I'm going to think of this as 9 times 3, right? And then I have these x's, okay? So here I have an x to the 5th, and here I have an x to the 1. Essentially, I have to do x to the 5 minus 1. That's going to be x to the 4th power. And here I have an x to the 1 power and minus x to the 3rd, well, divided, right? So this essentially becomes, I can think of this as y squared here, okay? So that's what I can do for this. And now it's going to simplify this. So I'm taking the square root of 9 times 3. Well, that square root of 9 is going to come out as a 3. This x to the 4th, I can bring that out. That's going to be an x squared. The y squared, I can also bring that out. That's just going to be a y. And so I just have left inside this, this 3 that I can't take out, right? So this is going to be what I get here. This essentially is going to be my final answer here. So it'll be 3x squared over y root 3. And we can consider any restrictions here, right? So let's consider if x was negative. Any problems there? Well, no, not really, right? If x was negative, this would be a negative number on the top. This would be a negative number on the bottom. They cancel out. We're taking the square root of a positive number. That's perfectly fine, right? We've got a positive number here. What if y was negative? Well, again, this is also odd roots here, so that's fine. I'm allowed to, this would be a negative over a negative. It would be a square root of a positive number there. That would be fine. But that does mean that what I get out here, this y, will always be positive, because if y is negative, these negative signs would cancel. Square root of a positive number will always be positive. So here, to be correct, I should actually take the absolute value of that y there. I don't need to take the absolute value of x because x is being squared. So x squared will always be a positive number. All right, so that's the restrictions here. X and y are allowed to be negative, but this number will always be positive. Let's look at the last one now. So for this last one, there's actually 2 ways that we could look at this. Well, more than 2, but there's 2 sort of different ways I want to look at it. Let's look at the first one. So the first one, I am going to essentially rewrite this as a rational exponent. So this is x squared y to the 4th power, all raised to the 1/3 power. And then here we have the same thing, x squared y to the 4th power, all raised to the 1/6 power, right? And then from here, we can take this and distribute that over the multiplication in here, okay? So what we'll have is x to the 2/3 times y to the 4/3 times x to the 2/6 times y to the 4/6. And now I can simplify a little bit further by combining things, right? This is the same as x to the 2/3 plus 2/6, right? Times y to the 4/3 plus 4/6. And now actually these fractions I can simplify a little bit. So 2/6 is going to be the same as 1/3 and 4/6 is going to be the same as 2/3. So this is what I've got here, and if I simplify that, I'm going to get x to the 3/3 times y to the 6/3, and I can simplify this a little bit further. X to the 3/3, well, that's just 1, so that's just x, and x to the 6/3, well, that's just 2. So there we go. This should all simplify down to x y squared. And are there any restrictions? Let's see, if x is negative, right, we would get a positive number here, and so then this would actually always be a positive number. Same thing here, if x is negative, that becomes positive. We'll take the 6th root, that's always positive. So x actually, technically speaking, must always be positive in our answer here. For y, well, if we have a negative y, it'll become positive, so the cube root will be positive. This will become positive, the square root will be positive, but y squared is always positive, so we don't really have to add anything there. So that's actually what we should get here. I want to show you another way we could possibly do this simplification. So let's think of this now. We have the cubed root of x squared y to the 4th and the 6th root. I want to think of that as the cubed root of the square root of x squared y to the 4th power. Because now that I've done it like this, what I can do is I can sort of combine the cubed roots here. So I'm going to have a giant cubed root with an x squared y to the 4th power multiplied by this x squared y to the 4th, and this is a square root, so I'm going to write that as a rational exponent of 1/2. Now if I distribute this 1/2 in, what do I get? Well, I'm going to get the cubed root of x squared y to the 4th power multiplied by, well, 2 times 1/2 is just going to be 1, right? So this is just x to the 1st power, and y to the 4th divided times 1/2 here. So 4 times 1/2 is just going to be y squared. And so now I can finally combine all of this together. I'm going to get the cubed root of x cubed y to the 6th power, and these are all perfect cubes. I can take them out, and I'm just going to get xy squared, the same exact number as we got before, and of course we can always add the same restriction that this must be an absolute value there. Okay, so there we go. We've gone through a couple of complicated practice problems here using rational exponents and different types of radicals, transforming them into rational exponents to try and manipulate them a little bit better. Come back next time and we're going to deal with what we call rationalizing a denominator. I will see you there.